Hi everyone. So here's review for exam 2 part 1. Okay, so we'll start with the first question. We want to find the average rate of change of f of x equal to x squared minus 6x minus 1 on the interval minus 1, 3. Alright, so here's the picture. If we have a function defined on an interval, like this one, let's say minus 1, 3, and I'm not drawing this particular function. So the average rate of change is equal to the slope of the line that connects these 2 points. This point is minus 1, f of minus 1, and 3, f of 3. So the slope is equal to f of 3 subtract f of minus 1 divided by 3 subtract minus 1. Alright, and that's the average rate of change. On the interval minus 1, 3. Now the instantaneous rate of change at a particular point would be the slope of the tangent at that particular point. Alright, so the function that we're talking about is given here above, so we're going to calculate first f of 3. So f of 3 is 3 squared minus 6 times 3 minus 1, and that's equal to 9 minus 18 minus 1, so that's minus 9 minus 1 is minus 10. And then we have f of minus 1. F of minus 1, that's minus 1 squared minus 6 times minus 1 minus 1. Okay, so we have 1 plus 6 minus 1, so that's 6. Alright, so we have f of 3, that's minus 10. Subtract f of minus 1, we're subtracting 6. And we're dividing by 3, subtract minus 1. So that's minus 16 over 4. And that's equal to minus 4. Alright, so that's our average rate of change on the interval minus 1, 3. Okay, let's look at the next question right here. Okay, so we have a projectile is shot upward from the surface of the earth according to the position function. S of t is equal to minus 16t squared plus 256t. Find the velocity when t is equal to 1. Well, the velocity function is the derivative of the position function. Alright, so velocity is equal to s prime of t. So we'll take the derivative, and the derivative of this first term, bring down the 2, and so we have minus 32t plus 256. So we want to see the velocity when t is equal to 1, so we're looking at v of 1, which is equal to minus 32 times 1, minus 32 times 1 plus 256. So that's equal to 200 and 24, and that would be feet per second. Okay, for B, at what time does the projectile reach its maximum height? So there we see it says at what time. Okay, so here we're talking about time over here. All right, and maximum height. Okay, so first of all, it's important to realize that the maximum height occurs when velocity is 0. That's when this particle is changing from going in an upward direction to going in a downward direction. All right, so that's upward direction would be a positive velocity and downwards a negative velocity, so in between it's 0. So we want to see when is v of t equal to 0, and then we'll figure out we'll solve v of t equals 0, and that's how we'll figure out what t is. Okay, so we have v of t up here, so just set that equal to 0 and solve for t, the time. All right, so we have, okay, this is equal to v of t equal to 0. We're setting it equal to 0, so we get 256 is equal to 32t, and divide by 32. And we get that t is equal to 8 seconds. Okay, let's look at part C. All right, now we want to know what is the maximum height, right? What is the maximum height? So all we have to do is sub t equal 8 into s of t. S of t gives us actual distances or actual heights, so it's s of t, a value of s of t that we're interested in. So we want to figure out what s of 8 is, because when t equals 8, the maximum height is reached. All right, so we have minus 16 t squared, that's 8 squared, plus 256 times 8. Okay, so that comes out to 1,024 feet. So that's the maximum height. All right, D, how long does it take for the projectile to reach the ground? All right, so the projectile reaches the ground when the distance is 0. So we're going to solve s of t equal to 0. That's minus 16 t squared plus 256t equal to 0. And we just can factor out the 16 over here. Or let's factor out minus 16. And we have, minus 16 times, or let's factor out actually minus 16t. Minus 16t. Okay, let me erase this. Okay, so we can factor out actually minus 16t from the expression above when we solve. All right, and here we have t minus 16. All right, 16 times 16 is 256. equals 0, which leads us to two values, t equals 0 and t equals 16. So initially the projectile is on the ground, but that's not the value of t we're interested in. The projectile returns to the ground after 16 seconds. Well, that's the answer there. Let's look at E. What is the velocity when it hits the ground? All right, so we're going to go to the velocity function. That's E. V of t is equal to minus 32t plus 256. So we want to find the velocity when t is equal to 16, because that's when it hits the ground. So we're just substituting in 16 over here, v of 16. Okay, so here we have minus 32 times 16 plus 256. And we get minus 256 feet per second. And since the projectile is going down when it hits the ground, it makes sense that our velocity is negative over here. And finally, the last question is the acceleration function a of t. Well, for all of these motion problems which depend on gravity, the acceleration is always going to be gravity, which is minus 32 feet per second squared. So if we differentiate the velocity, that's what we get. That's only in the case of examples of objects that are free falling. In other words, their movement or their velocity really depends on gravity, which is the case here. So here, a of t, that's the derivative of v of t, so that's minus 32 feet per second per second. So that's feet per second squared. That's the way we express that. Okay, that's the end of part 1, and we'll do in part 2 we'll start with problem number 3.